Hello friends, welcome to this video. So in this video also we are going to discuss another question which is asked in 2021's JEE Main. So let me read the question, then we will analyze it. So what is the question? A ball with a speed of 9 meters per second collides with another identical ball at rest. After the collision, the direction of each ball makes an angle of 30 degrees with the original direction. What will be the ratio of velocities of the balls after collision? So let us understand the question. So we have one ball here and another ball here. This ball is having a speed of 9 meters per second moving in this direction with this ball. This ball is at rest. After collision, each ball makes an angle of 30 degrees with the original direction. Suppose the original direction is this horizontal direction, okay? So then this ball makes like this ball, first ball goes like this, second ball goes like this, and in each case the direction of the ball after the collision is 30 degrees, okay, with the original direction. Suppose the original direction is the horizontal direction, x direction, and perpendicular direction is the y direction, okay. So based on this, rest of the calculations I'm going to show you now, but before that I have to remove this all the drawings here. Okay, so here we have again one ball, another ball moves along this direction, and there is a collision. This is the original direction. After the collision, the first ball moves in this direction, second ball moves like this, and in each case the angle made is 30 degrees. So what we have to find out the ratio of the velocities of the balls, okay, the ratio of the velocities of the balls after the collision, okay. So each ball is said to be identical. Identical means, let us assume that the mass of each ball is m, okay. So after the collision, so okay, in such a case, in such a collision, the momentum is always conserved, okay. Momentum is always conserved. So why is momentum conserved? Because there is no external force, okay, no external force. Therefore, momentum is always conserved before and after collision, okay. So initially, what is the momentum along the y-axis? So for simplicity, we will consider the momentum of the two balls along the y-axis, okay. This is x-axis and the y-axis, okay, minus y-axis suppose. So initially the ball is moving along the x-axis or the horizontal direction. So all the momentum will be along the x-axis. So the momentum along y-axis will be 0. Okay. The momentum along y-axis will be 0. So what will be the momentum along the y-axis after the collision? So suppose this ball has a mass of m, this ball also has a mass of m. Suppose the velocity which this first ball attains after collision is v1, and the velocity which the second ball attains after the collision is v2. Okay. So again, let me write here. So momentum initially is equal to the final momentum. Okay, initial momentum is equal to the final momentum because force is absent. Okay, force is 0. So basically, the principle of conservation of momentum we will use. So along y-axis, initial momentum is 0. Pi along the y-axis is 0 initially because the ball is moving along the x-axis. Okay. So here also we will consider the momentum of the balls along the y-axis. So momentum is mass multiplied by final momentum. What will be the PF. Let me write it PF. Okay, so what will be the final momentum? Final momentum will be mv1. This component, this perpendicular component will be sine of 30 degree. Okay, and there will be another component of momentum which will be vertically downward. So since this second momentum is vertically downward, so we will write it as minus m v2 sine of 30 degree. Okay, so this value of momentum would be, let me just write here, mv1 sine of 30 degree, and downward it will be mv1 mv2 sine of 30 degree. But since this momentum is downward, so the net momentum would be mv1 sine 30 degree minus mv2 sine 30 degree. Okay, and the initial momentum along the y-axis is 0. Okay, that we have discussed here, because the ball was moving horizontally initially. So let us simplify and see what we get. mv1 sine 30 degree is equal to mv2 sine of 30 degree. Fine. So m get cancelled. Sine of 30 degree get cancelled. So what is left? v1 equal to v2. So what was the question? The question was that we have to find the ratio of the velocities of the balls after the collision. So v1 equal to v2 is what we are getting. So v1 divided by v2 will be equal to 1. So this is the ratio of the velocities of the balls after the collision. So v1 ratio v2 is equal to 1 ratio 1. So this is the required answer. So I hope you have understood the solution. Just use the principle of conservation of momentum. When force is absent, momentum is conserved. We all know very well. Now consider the momentum of the balls along the y-axis. Okay, it becomes easier to solve. And we finally get that since the initial momentum along the y-axis is 0, so final momentum will also be 0. But final momentum value-wise, you should write. So the momentum value vertically upward along the y-axis and momentum value vertically downward along the y-axis. So we will eventually get v1 equal to v2, and the ratio is equal to 1. So I hope you have understood this solution. Please like the video, share it, and also consider subscribing to this channel, because I am going to upload more such videos in coming days. So thank you very much for watching, and see you in the next video.